Hey gang, you guys back? I'm gonna give you a minute and get back. I'll try and block that sun. I think I might have to quit, you guys. This is just... I'm not gonna be able to do that. I give up. It was a disaster. Hey guys, welcome to my disaster. Oh, what a mess. Can you see me? Is anyone here? I'm so sorry, you guys. I hate YouTube. It's so bad. It's so bad the way they do this live thing. Okay. Hi. Welcome back, you guys. Sorry about all that. All right, where were we? Okay, anyone here? Oh, you know what? I gotta fix the chat. Sorry, because of YouTube's deal, I gotta change. I see why I can't see you guys. Bear with me, gang. We'll get there. I'll get this figured out one of these days. Okay. Phew. Well, you can't see me probably because of the sun, and I can't see you because of the sun because my computer screen is totally washed out. But welcome back, everybody. Man, those technical difficulties are so frustrating. All right. Well, welcome back, you guys. Another episode of Stove Chat, episode 28. Happy Wednesday, you guys. Hope you're having a good one. Sorry about the technical difficulties. We're just gonna have to deal with this washed out screen. There's nothing I can do. It's just awful. But it is what it is. So let's see. How are you guys? Hope you guys are getting into the season here. Manny, nice to see ya. Iron Bridge, thank you for laughing with me. Golly. Okay. I'm just gonna be over it. So I'm a real person. I'm having a heck of a run, beginning a great start here. This is just a disaster. So okay, guys, let's see. Let's get on with it. Oh, YouTube sending me all these notifications about live stuff. Okay, so hey, gang. All right. So let's see. Stove chat. I did have some great stuff in my mind to talk to you about. I've totally forgotten all of it, but I'm sure it's going to come back to me. Does anyone have any questions about their stove builds? That would help a lot right now. I'm totally just discombobulated. Let's see. So yeah, so I don't remember where we left off last time. Probably just talking about stoves and looking at builds and stuff. I did get some awesome emails this week, you guys, and there's some great topics in those emails, and so there's some good stuff to go over there. Got some builds to look at, which I'm really excited about, and yeah, and that's it. And I've heard from quite a few of you guys who are starting your builds, and I know that some of you guys have questions as well, so feel free to throw them at us in chat, and we'll work our way through them despite the technical difficulties here. So one of the first things I wanted to talk about was general chimney, what should we say, guiding principles, I suppose, and just really chimney talk, let's call it, because it's one of the most common questions I get is a lot of the specifics about the chimney, and often I'll get questions from people who want to do things with the chimney that are really far outside of what one would consider normal, chimney kind of rules or standards. And so I wanted to talk a little bit about those things and sort of, talk about the normal chimney rules, as it were, the normal chimney installation guidelines, and how those sort of, how those relate to rocket stoves, because I do think that there is some confusion out there that a lot of people want to have special chimney rules or chimney guidelines for their rocket stove builds, and so I think that's something that I'd love to talk about. So let's do that a little bit. So first and foremost, we know that the chimney provides the draft, which really powers the stove, right? It gives you all of the draw that gets that air moving through the stove comes from draft, which is really, for the most part, to put it simply, a difference in temperature between the intake and the exhaust. There's difference in pressure and other things as well, but just to sort of simplify it, we'll just talk about the difference in temperature between the intake and the exhaust of the chimney. And so, for our rocket stoves to run smoothly and to always have, that passive draft induced into them, so they're burning efficiently, so they're burning enough air through the fuel to get the proper mixture, and so that they're not smoking back, we need to maintain that draft at a certain level. And of course, that draft is always going to be fluctuating depending on conditions inside and outside and all those things. So general chimney rules for average, box stoves or normal box stoves are a pretty good place to start. And I don't have codes or guidelines right in front of me, but I know general rules. And for the most part, what we want to do is we want to exit vertically as possible out of the stove. We don't want to descend after the stove at all. We'd like to just try to ascend. And ideally, we try and ascend with as little diversion from our main direction, our main goal as possible. So we don't want elbows if we can avoid them. And more importantly, we want to try to maintain draft within that chimney. And so that means we really want to try and maintain temperature within that chimney. And that's one of the main reasons why insulated chimneys are so effective. So these are pretty basic concepts. I know I'm not covering anything groundbreaking here. But ideally, your chimney is going to go out of the stove and straight up through the roof and out. Now, that isn't always possible. So it's also acceptable to go up a little bit, maybe 90 degrees sideways for just a few feet and out the wall and then up and out the outside of the building. That's typically going to be okay as well, although every little bit of horizontal chimney and every 90 does contribute to reducing your draft a little bit. So you want to eliminate as many of those as you can. Now, what I was talking about the difference in temperature and trying to maintain that temperature in your chimney, that's an important thing to consider, because if your stove is extracting the maximum amount of heat from the exhaust, then you're going to be putting the exhaust into that chimney at a very, fairly low delta, a fairly low difference in temperature. And so you want to maintain every degree you can from there all the way out. So that implies you want an insulated chimney. Now, what I'm trying to get to here is that how insulated or how crucially, how important your chimney's design is really depends on your front end design. So some people will build their stoves and try to run them such that they are extracting every last bit of heat. In a stove like that, your chimney efficiency, let's say, is going to need to be absolutely perfect, because you haven't saved any heat in the exhaust to help power that up through the chimney. So if you lose any, it's going to be detrimental. So really what I'm trying to say is, people will say, well, Matt, can I put a couple elbows in my chimney? Do I have to use an insulated chimney? Is it possible to go through the wall? And my answer to all of those questions really is, it depends. And it's going to be a tuning issue at the end of the day. And so, again, going back to one of my favorite topics is the bypass. I always have bypasses in my stoves, or something I call a passive bypass, just due to the nature of the design, to help drive draft. And, those give you a lot of leeway in all of these other questions. How big can my bell be? What kind of chimney can I get away with? So that's an important, thing to understand, that if you are trying to keep every last bit of, drop of heat in the stove and in the house, then you need a perfect chimney. Most of us have some compromise in there. Most of us are not doing perfect heat capture, and so we're usually going to save some to power the chimney. And personally, I find it's really valuable to allow for some extra to go in the chimney, and by that I mean my bypass. It allows you to overpower the chimney and get yourself out of smoky cold start situations, get yourself cooking in the summer. There's a lot of reasons to do it, but more importantly, it just gives the stove a really broad, really smooth working range. And so that's why the bypass allows you to get away with some different things with regards to chimney design. A little more, you can design a little more loosely. But what I really wanted to talk about was some of the questions that I get from people who want to do something just completely outside of normal chimney suggestions. And I believe that these are holdovers from the old Yanto Evans book of rocket mass heaters, and how he preferred to run his exhaust horizontally through the wall, despite the fact that it means a stove that is really finicky. And so we have that legacy still, where there's people who read about rocket mass heaters and they think, hey, this is great, I'm going to be able to run my exhaust out the wall and not have a vertical chimney. And, we've talked about this before, but I just want to reiterate that if you don't have that vertical chimney to power the draft, you're going to have times when the stove smokes back into the room, times... yeah, Iron Bridge Homestead. Oh, that Yanto. I mean, he's a spicy character, and I love everything he's done for us, but we do have to go back and now and then and explain that some of, the choices he made aren't going to be appropriate for everybody, and that's really what I'm saying. And Pete asks, can you, in the case of harvesting, of too much harvesting of heat, leave that bypass open just a crack? And yeah, Pete, that's exactly what I'm saying, is that once you have that bypass in there, you really have the ultimate control. You could have a giant bell, and you could just crack your bypass a little bit, and you'd always be powering your chimney with some heated air, but just a little bit. So the bulk of your flue gas volume has to go through that big bell. And in that way, you can draw the gases into a bell much faster than they would go in just a passive system. And so, you might have a situation where if you didn't have that bypass, you'd be struggling hours to start up. Whereas if you have that bypass, you can just kind of crack it a little bit and just pull heat through the whole system. Stove looks like it's burning great right from the get-go, and you're already starting to heat up your bell, even though you are blowing a little out the chimney. It's much better than blowing smoke into the house. So I'm a big fan of that, and that's why I like the bypass, because you can really incrementally adjust. It just allows you to overcome all of those conditionally, the things that are the situations that are caused by different changing conditions. You can change your stove to meet the needs of whatever those conditions are. So yeah, and Iron Bridge, totally. He said, Iron Bridge Homestead says, Yanto's book was informative, but we've grown to understand other methods work better for sure. And yeah, and that's how I feel, Iron Bridge Homestead. I absolutely agree with you, but I would give Yanto the credit and say that it's not that he didn't learn the things that we learned. It's actually, I think it's the opposite. I think he was ahead of us in a lot of ways. I think he's much like me. He just says, here's what my goals are. Here's what the compromises are. I choose this. So he chose that exhaust out the wall, despite how finicky it was, for a host of reasons that he had that were his personal reasons, but that was his choice. And frankly, I think it's kind of genius. I think he moved in a lot of ways beyond what we would recommend to anyone just building their stove, because it's not like that's for someone advanced. It isn't that. It's that's for a crotchety old guy who knows exactly what he wants and is and believes in this, the compromise, this theory gives him these advantages at these disadvantages, and it's worth the trade-off. And so I really like that. a lot. So, and yeah, Iron Bridge, we can't forget Kiko either. And Kiko is great. I've actually gotten to spend some time with Kiko in person, and he is just an unbelievable wealth of knowledge when it comes to the clay and the plasters and the masonry, building in the natural building sphere. And yeah, those guys, they deserve more credit than I could ever give them, to be honest. I was so inspired by them. So anyways, going back to chimneys, I wanted to just finish up the main question I got. We talked about, ideally you're going to have a chimney that looks very much like the chimney on a box stove. Ideally it's going to conform to the same guidelines. But I get a lot of questions from people, and like I said, I think it's from people who, not necessarily maybe that they read Yanto's book, but where there's just a legacy of people, out there saying, oh, rocket stoves don't need a chimney, or I heard they don't need a chimney, or whatever. And so I do get a lot of questions from people asking if they can run the exhaust from their stove under the floor and out the wall, or across the room, and down. Sometimes people want to go down and dump it outside, and I think that is to me that points towards Yanto's legacy. But I want to talk about that because I really want to work hard on dispelling those ideas. I don't think anyone's foolish for thinking them. I don't think anyone's foolish for wanting them. I mean, it would be awesome if we could. And frankly, we talk about rocket mass heaters often. We talk about our builds, and we talk about bringing the gases below the core. So we do have descending gases, and they do go low quite often. So what I wanted to talk about in this chimney discussion was the difference between when the gases are in the stove, in your masonry body of your stove, or when they're in a chimney, and how you should really consider those two parts of the stove to be completely separate modules. So don't look at the stove and go, well, we can have these descending gas paths, so it must be okay for the chimney to go downhill, because that's not the case. Once you're in the chimney, you are typically for most of us aren't going to be using Class A triple wall insulated pipe. Most of us are going to be using non-insulated pipe. And so that chimney flue pipe typically represents a really, a pretty efficient radiator. It's cooling the gases quite quickly because it's shedding that heat into your space. So those single wall flue pipes do a really good job of removing heat from the exhaust gases, and in doing so, they really can harm your chimney's efficiency. So I use it, single wall stovepipe. It's fine. You can use it in vertical configurations. You can use it for a short run of horizontal. But basically what I'm saying is the farther you go horizontal or down, it's just going to act like another barrel radiator in your stove. It's going to remove heat from the gases, and it's going to impede draft. So when people ask me, can I come out of the stove and then go down? I'm always going to say no. And I'm always going to say I think it's a bad idea. Now, does that mean you couldn't get it to work? No, it doesn't mean you couldn't get it to work. You might be able to get it to work, especially if you had it, returning and coming back to a bypass and you had a vertical chimney at the end. You could power up something like that in a time of need. But you're going to have, anytime I think the main point I want to get across is that when you compromise your chimney flue path, you're going to compromise the stove's performance overall. And you're going to have hard starts. You're going to have smoke in the house. It's just going to be a lot more trouble than it's worth. So I know cutting a hole in the roof sounds awful. Believe me, it terrified me for a long time. But I think that most of you will find that it's actually a relatively simple job, and it usually beats all the alternatives. Even going through the wall and going straight up, for most of us that means you're going to run into the eaves once you get up there, and you still have another something you have to deal with, a lot of work either way. So I find it's easier to just go straight up. And with that said, I will say when you're laying out your stove and trying to find where it's going to go, it's a really good idea to start from the chimney exit, because you're going to need to go in between rafters or beams up on the ceiling. And so it's a good idea to make that hole, use your plumb bob, drop it down there, center your stove's chimney exit on that plumb bob and build around that. That's usually the best way to go about locating your install in your space. You can get it close on the floor, look up, figure out where the chimney goes, plumb the chimney, and then you're good to go. So Manny, great to see you here, man. Thanks for being here. I really appreciate you, my friend. You and I'll have to talk in private at some point, but thank you for all your input over these weeks. And Manny says, I just added a bypass to my heating stove this weekend and learning the new dynamics of the stove. And that's a really, really, really great observation, Manny, because I have often been thinking about you. Manny's in a place that has very warm air temperatures compared to most of us. Although I imagine in the mornings you get a little bit of delta. You must be probably 50 degrees in the mornings or so at your coldest. But at any rate, Manny doesn't have a ton of delta to work with. He doesn't have a big difference in temperature when he's starting up. And so, he lives in a moderate climate. And I always, my stoves are designed with bypasses, so I'm not too concerned. But I see people building stoves in moderate climates, and I am always aware that the startup issues become even more pronounced when you don't have the big difference in temperature. So we can notice it in any climate when we're trying to burn in the shoulder seasons. It's harder to start when your stove is cold and it's a pretty warm day outside. You don't have much difference in temperature. It's always going to be the most difficult starting conditions. So if you live somewhere like that, I think a good functioning bypass is mandatory, and I think the ability to just crack your bypass and slightly power up your chimney to get through some of those times when you don't have a lot of natural difference in temperature is really, really valuable. So yeah, Manny says down to 57 last night. So that's cold for where Manny is, and that's a challenge for a masonry heater. It's not a huge challenge for a box stove, because box stoves, keep in mind, a box stove, the exhaust is right on top of the firebox. So almost the instant after you light it, you have heated gases in the chimney powering your draft. But in our masonry heaters, the gases have to find their way through a big serpentine of cold masonry first, and that robs all the heat, usually entrains moisture into the gas, and you just have a real hard time getting started if don't have that big difference in temperature. So that was a long topic that sort of came back around to bypasses, but more importantly, I really wanted to touch on chimneys in that topic, and just encourage you, if you're looking at a build, thinking about starting your build, just encourage you to do your best to plan for the best chimney that is possible in given your situation. I think most of us have done builds where we've compromised our chimneys because we think it's going to make things easier or get us a little better location or this or that, and usually end up disappointed because the heaters really aren't any good unless they're great. If they're not working, it's part of your life, right? You're going to use it day in and day out, ideally, and so you just don't want to be fighting with it every day, I guess is what I'm getting at. So there's that. That's the chimney discussion that I wanted to talk about. So, Manny, I'd like to hear about your bypass if you'd care to type. I know you're probably working right now, so no big deal. But I'd love to just, if you get a chance, just simple, overview how you did your baffle. Is it external or internal? I guess that's mostly what I'm wondering. I sort of picturing in that small little stove that you might have done an external bypass, but I'm not sure. So how about the rest of you guys? Who's working on a build right now? Does anyone have any build questions we need to go over? Mark, I see your chat finally found me. I know that was a while ago. I apologize. YouTube doesn't make getting around in their live streaming software easy. Once you've lost the one stream, trying to find the code again to restream so you don't have to go find me, it's a mess. I apologize. So I keep thinking it's gonna be smooth as silk every time, and then something throws me for a loop. So I apologize for that. But anyways, that was a great question I had on that. I've got another question which I don't know if I'll really be able to answer here. Oh, here's Manny's reply. Manny says, I just added a T to the chimney at the top of the stove with a traditional cast damper plate, and that's exactly what I was thinking. So that's what I call an external bypass. And so those of you who are following along, basically, let's I'll just use this. Imagine this box as your stove body, and your exhaust is typically going to come out of the bottom of your stove body, right, and go up. And so actually, this is I got a wonderful email from Lubin, I think was his name, in Bulgaria. Lubin, if you're watching, if you catch up on this, this is something that you could use for your bypass if you decided you ended up wanting to do one as well. So this is what I call an external bypass, and this is what Manny did, I'm assuming. Here's his chimney coming up out of his stove. So when he's burning in his stove, the gases need to descend, they're getting cooled, and then they enter the chimney, and they go up and out. And that works fine, but when the stove's cold, they're very cold when the gases get here, and they're not going to be motivated to come out. So all you need to do is do what I call an external bypass. You can just put a T in the chimney up here. So the chimney's going this way. So here's your T. Here's the trunk of the T. And that then goes into your stove up high. And then you can put a damper in it right here, open and closed. So now when you light the stove, your gases can go out the damper and straight up the chimney. And in that way, you can do an external bypass without building the body of the stove any bigger. Your chimney's still in the same location. You just add a T and another hole into the stove. So that's what I call an external bypass. It's a great, simple solution to just get yourself some startup time. And as Manny says, he says, I'm losing a lot of heat out of the damper even when closed, so he may strap a piece of fiberboard to the damper. And that's always going to be an issue, Manny, especially with, if you're using a commercial fireplace damper that's designed to go in 6-inch flue, they are always going to have holes all over them because they are required by code to not be able to completely close off the flue so that any carbon monoxide or residual flue gases can find their way out. So there's something called a blast gate that's used in big dust collection systems and air handlers and vacuum systems and things like that in industry. So you could Google the term blast gate. You could look up 6-inch blast gate. And a blast gate is just usually a round, flue pipe flange with a sliding gate in it. And those do give you pretty complete closure. Now, with all of that said, one thing about bypasses I've found over the years is that I don't feel that really hermetically sealed a hermetically sealed damper is crucial, because once the stove gets warm and everything's burning hot, the gases are going to prioritize towards the big open flue path, even if it's convoluted and all the way around. There's going to be so much back pressure on those little holes in your bypass and such easy non-restricted flow once we have draft at the back end of it through the stove that the stove gases will prioritize flowing through the stove. Now, of course, that requires getting the stove warm. So if you're just bypassing for a single fire once in the morning, then the bypass is going to leak quite a bit of heat and you are losing some. So piece of fiberboard is a good way to do that, Manny. You know what I found works really well is the wool, the more flexible, not stiff board, because it you can kind of wrap it around that whole damper and kind of wire it to it. And it'll make sort of a soft, fluffy, a big fluffy muffin in there that closes things off. Whereas the ceramic fiberboard will do the same, but it kind of just wears away eventually. The blanket will stay there and block things pretty well. So that's what I recommend. Tape up all the holes, obviously. So, but that's that. Yeah. So that's bypasses, and like I said, I don't feel like it's super crucial to agonize too much over the holes in them, but you can, there are some steps you can take to do that. So, all right. Well, the sun's out of my face. It's getting a little better here. I wonder if I can get this thing to brighten up a little. Boy, it's just so bright back there behind me. All right. Well, Let's see. There's Mark. Hey, Mark. Thanks for finding us, by the way. I apologize. So Mark says, I just screwed a round piece of sheet metal to the damper plate and a stop screw to know when it's fully closed. And that's great. And so, yeah, any action you can take to get it as close as you can, and beyond that, I would say just don't agonize over it, like we were just talking about. You don't really need to worry if it's hermetically sealed, but yeah, you just do your best. So a round piece of sheet metal is great. You must be better at cutting circles than I am, Mark, because I've tried that, and the way they go in the flue pipe, I always have a elliptical side poking out, but that's just me and my gotta get it done in a hurry style. So there's that, and actually all of that conversation with those flipping bypass dampers and blast gates just brings me to one last point, and that is that while I use those flappers often, and they are very convenient if you're doing a simple bypass like Manny did, if you have the option, you definitely want to use a sliding one, more of a gate than a baffle, as it were. The gates have the ability to be a lot, like you could have a small hole in a big gate that just kind of obstructs the whole thing without really any wear or any chance of it over time reducing in size. It's just easier to get a better seal, I guess is what I'm trying to say. So, and Mark says his is about 98% sealed, which I think that's great. I think that's all you need. And once the stove is hot, I really don't believe you're probably bypassing anything through that 2%. I don't think it can. I think it's going to represent such a restriction compared to the other direction that flow will naturally prioritize the other way. So, and you can see that actually if you have a stove with a bypass and the bypass doesn't close fully. The flapper ones you won't see it, but in a sliding gate one inside the stove, when you disassemble the stove to clean it, you'll see all of the black stuff that piled up where those holes used to be, and the bypasses typically will plug themselves. They will obstruct any small openings. So there's that. So let's see, what else can we talk about? I've gotten some great questions this week. Excuse me. One of the great ones I got, we talked a little bit about it last week. We were talking about sand, and we were talking about round sand and sharp sand and the way those things build up in the mortar joints and how those come together. And so I just wanted to reiterate that while it's fine to use found sand and it typically will work for most people, I've found that there's a lot of value, and this actually goes for clay too. I've found that there's a lot of value in just purchasing sharp silica sand, mason sand. It makes such a big difference in the body of the material and the way it holds up under the weight of the bricks, that these days I usually just go right to the bagged product rather than trying to source it myself. And not only that, but usually if you find, go digging your own sand, you usually have pebbles in there, things like that. You end up having to screen it and all those things. So just want to touch on that. I got some questions about how important was the sand, and while it's not crucial, you can certainly build with found sand. Sharp sand does make a big difference. It's really inexpensive, and you can really speed your build along if you have the good stuff clean in a bag. And the same goes for the clay. While it's nice to use found clay and it is cheap, fire clay really is fairly affordable, and just starting from those bagged products that don't need straining or breaking up or mixing in a traditional sense. They do need mixing still, but it's just so far superior way to get working fast that I highly recommend it. So a lot of questions this week were about materials, and then another one I get is the amounts of materials. And as you guys know, all my plans, there is a bill of materials there. They do have suggested material amounts, but everyone's build is different. And so everyone always, writes me and says, how much fire clay am I going to use? And I just want to say that this is such a hard question to answer because everyone's going to use it differently. Even the thickness of the joints, how much you waste, how wide the joints are this way, the viscosity of your mix. You're just going to go through it at different rates. So I would say use my guidelines in the plans as a starting point. If you're adding another bell, go ahead and just double that amount. You'll be thankful to have some extra on hand. But that's something that I get questioned a lot on, and I think probably the best thing that anyone can do is just have enough on hand, because down the road you'll be using some for patching. Just don't be scared. Just get enough. So typically for a stove like the tiny stove, it's only going to be usually 120 pounds or so, 2 60-pound bags, or 3 as you add another bell, maybe another bag or 2. But we're only talking about maybe, I can't remember what I paid for my last bags. I want to say they were like $30, I think. I can't remember. But you're not going to spend much on the clay, and it'll save you so much time and effort. So Ironbridge Homestead says, what about mortar for fire bricks? I saw the pre-made buckets of high-temp mortar, and would those suffice? Well, Ironbridge is a great question, and it really depends on where in the stove we're talking about. I don't care for the high-temp mortar anywhere, and the reason for that, we've talked about it before, but the reason for that is because any of those mortars that you purchase that are commercial grade, they are setting mortars. So they are made to set hard. Like concrete hard. And in my experience, those are always going to crack. Not everywhere. They're not going to fail entirely, but you're going to get some cracks. And once they've cracked, they just stay cracked, and they grow because the heat expands a little bit, and a little chunk of sand gets in there, and it stays open, and that just continues to happen. And you can't really fix it. And when you take it all apart to fix it, you have hard mortar stuck to all your bricks that needs to be broken off. So I have found that the clay sand mortar, just the simple clay sand mortar, is the superior mortar for all areas of the rocket stove. It's flexible, it's repairable, it's removable. If it does crack, you can just wet things down with your finger and get back in there, and seal up the cracks. If you take it apart, you can just dip them in buckets, wash it off, and reseal. I really, really, really prefer clay sand mortar to any setting mortar. Now, in the cores, there has been various techniques about when using fire bricks in cores, various techniques for mortaring those together. I gotta say, I'm coming around to have the mind that as long as your core is captured in an appropriate stove body that's all hermetically sealed, I don't really feel like there's any need for any mortar in the core bricks. There's some builders who like to use clay slip, but I don't think that does anything. I think that once the thing is put, it holds it together when you're building it, and that could be useful. But for the most part, your bricks are in there dry stacked. As soon as you start burning, they grow and shrink and move, and they break their mortar joints. They're really just like the CFB. They're just sort of a loose core configuration captured within a stable external shell. And that's how I like to look at it. And so, to answer your question, Ironbridge Homestead, I don't think there's any reason to use high-temp mortar. I think if you're mortaring fire bricks for the external part of the stove, I'd use clay sand mortar. And if you're talking about the core, I'd probably just skip the mortar entirely on the inside surfaces, and just make sure that you have the whole entire outer part of the core well sealed, hermetically sealed, in an outer skin, cob, outer skin of mud, whatever it might be. And that brings us back to another topic that I wanted to go over today, which was there was a great post on Donkey's board about a fire brick core. Oh, Pete says not even mortar for IFB, meaning not even mortar insulated fire bricks together. I'm sorry, I should qualify that. there's nothing wrong with using mortar inside your core, but we've always tried to do is we've used slip or really, really thin mortar to try not to create spaces between the bricks. You know, when you build the rocket stove cores, you almost never have a visible joint, right? You just put some stuff in there. And what I've come to realize is that we're not really, the core is kind of locked together through the nature of its stacking function. There's weight on these side pieces. These can't fall out. The mortar isn't really doing much for us. It might be filling some little imperfections in those IFBs. But yeah, Pete, I think I've come around to the point of feeling like it's probably not doing much for us. I don't know that there's any value in putting mortar in the core bricks. I just, the idea was maybe we're going to seal some little imperfections in there, but we're talking with the IFBs, we're talking, 2.5 inch thick, at the, on their faces where they're mating. It's a lot of distance for there to be an open gap. And on the other part of that is if there are holes in them, they should be going to the outside of the core. It should be filled with mortar or mortared to the external skin, or they should be all sealed from the outside anyways, I guess is what I'm trying to say. So unless you had a real obvious problem, like you're fitting your core together and maybe like the center divider has a big gap in it, you would want to fill that gap. But just as a general rule, I would say there's no reason to really stick them together with mortar. No, you certainly can. You're not going to hurt it by doing that. But this is because I actually just got a question via email from a dear friend day before yesterday, and he is building his second or third stove with a Walker riserless core, and he emailed me and said, "Hey, Matt, I seemed like last time we mortared the core together, but I don't really see why we did that. It didn't really... We didn't put any space in between the bricks, and at the end of the day, when I took it all apart, the mortar was just kind of gone or not sticking them together anyways. What is it there for?" And I was like, yeah, if we're building the core as a core and it's just inside and sealed within the stove, I don't know that there's really much reason for mortar between those bricks. And I do think that something like a high temp mortar is going to make more problems than it's going to solve, to be honest, because you will get different expansion and contraction rates, and you will get cracks and things like that. So I didn't get to say hi, Tall Shadow. Glad you're here. Thanks for showing up, even if you're late. We had a rough morning. We had a rough start, so you didn't miss anything. I had technical difficulties. So David Swanson says, try Rutland products in some areas. Also use Permatex muffler and tailpipe sealer in firebrick cracks. So, David has a great approach to this, you guys. And that's kind of what I think is the way we should look at this. Is rather than just mortaring our cores together because it seems like they should have mortar, I think a better approach is to go, where are the leaks, and patch them. So, as David says, he found some firebrick cracks. He filled them with some sealer, and that's good enough for him. And frankly, I think that's really kind of the approach we need. And when you're building most of these cores inside a sealed container, that's not going to be an issue. And as Ironbridge Homestead says, even the high temp mortar is designed for 3 millimeters max. So we're talking about real thin joints, and I don't know what that joint's going to gain you inside that core, especially in an area where the temperatures are so dynamic. It just doesn't have much chance of holding up, I don't think. So there's that. That's talking about the mortar within the core, and why you may or may not need it. So Tall Shadow says, I guess no mortar if your bricks are not in need of leveling. Right. Tall Shadow, I'm sorry. That's you just pulled the detail out that I was having a hard time finding. Right. So new, good, crisp bricks will fit together nicely, tightly. But sometimes your bricks need to be leveled, or they have chips or gaps that are not perfectly shaped. That's when you're going to use mortar. Anytime you have an unstable, foundation for the next brick, then you might use some mortar for setting. If you're buying all new, crisp bricks, you shouldn't need it. But as David Swanson says, the sealer cement just holds the fire bricks from moving a little, so the cracks don't get worse too quickly. And that's That's it. That's really the point. So, you know, like I said, we're using sort of the bigger IFBs. They have pretty big mating surfaces. They're going to settle in there pretty stable. But sometimes you get odd shapes, old bricks, you know, bad cuts. There you're going to use mortar. So hopefully that makes sense. Let's see. I had something. There was something in my along that path that we were talking about the bricks that I was hoping to get to, but I think I lost it. There was a good tidbit in there, but I forget what it is now. So, but at any rate, that's my take on that. And going back to the mortar and the skin, we've talked about that a bunch. But same thing. Ideally, just that clay sand mortar for those same reasons, just so you're not having to clean off that setting mortar. And yeah, if you're too aggressive, as David Swanson says, then those cracks and things can help. Okay, I do remember where I wanted to go. So, on that note, we were talking about fire brick cores, and I just wanted to go back. There was a great post on Donkey's Forum this week, and it was from Dan in upstate New York, who's been a long-time poster, someone I think many of us have communicated with a lot and gotten a lot of great observations from. He's been a long time burner. He's got a really cool build, and I just wanted to comment on his teardown of his fire brick stove. So it was a dense fire brick J tube, kind of just a standard rocket tube or rocket stove build, and he has had it for 7 years, normal use, and it was a full heavy fire brick build, like heavy fire brick core, heavy fire brick riser. And this year was the year that he took it apart to rebuild it, to do his maintenance, because he knew that his burn tunnel, so the top of the J tube burn tunnel, he knew that at least some of those bricks were compromised and it needed to be replaced. So he went and took it apart, and as it turned out, I think there's 4 brick up there, maybe a few more, but they were all completely cracked apart and failing badly. In order for him to replace them, he had to remove his riser too, and so now he's going to replace that heavy brick riser with a 5-minute riser. So in the future, replacing those burn tunnel bricks are easy. But the reason I wanted to bring that up is just to illustrate this point that we make all the time on Stove Chat, and that is that all wood-burning devices, to my knowledge, have wear parts. They have consumables. You are gonna have to you're going to have to repair some things sometime down the road, replace some parts sometime down the road, and it's important to go into your build knowing this and make your choices appropriately. So I have made my decisions. My ceramic fiberboard builds, they do have some abrasion wear in the firebox. You can take care of that with liners, or you can just replace them every few seasons, whatever it might be. The secondary air, my RA330 seems to be permanent, but if you can also build those secondary air tubes out of mild steel and replace them yearly. So I just thought that Dan's experience was really good illustration that no matter what construction method you use, the elements within a rocket stove firebox are just, it's too much to ask for it to be a zero maintenance construction, no matter what construction you use. And so I just wanted to bring that up because that's one of the biggest questions I guess. People say, I think I'm going to go with fire bricks because I don't want to tear it apart in a few years. And I just really wanted to illustrate that it's not that I want to illustrate that fire bricks aren't any good or that they're worse or that they're just as bad. What I really want to illustrate is, hey, even if you're building with fire bricks, make sure you build it in such a way that you can maintenance it, because you will have to. And I think that's one of the biggest concerns I have is when people say, well, I'm looking for a really no maintenance stove, so I'm going to build it with these heavy duty fire bricks, even though, I know you like the insulated stuff. And my biggest concern isn't that they're not going with the insulated stuff, it's just that they're going to, build themselves into a corner. So again, just reiterating, all of these stoves I think are going to need maintenance. I think it's really wise to build yourself important, easy ways to access those things. Pete says, we don't have Hardy Backer board here. Any ideas what I could use or look for instead? Yeah, Pete. So you must have, something similar. I would imagine there's got to be some cementitious board. Try that search first of all. Cementitious board. It's a funny word, but you should be able to figure that one out. You can also look for tile underlayment. That's typically what it is used for. I know that in Europe you guys have that Schluter system, which is that orange plastic hexagon underlayment that goes under tiles. That's a really, really that is the modern popular way to lay tiles. So Hardy Backer may be harder to find, Pete, but look for use the word cementitious board, tile underlayment. And then I would start looking, some of the things that Hardy board is popular for that I would imagine it's used for there as well are things like shower stall installations. It would replace like the drywall against the studs in a shower stall. And another one is like outdoor kitchen builds. You'll often see it used on steel studs for any kind of outdoor, bars or kitchens or things like that. So I suspect, Pete, that if you just call a few contractors, it must go under a different name over there, but you should be able to find some cementitious board of some description, I would imagine. I mean, it's really, really widely used in construction over here, so I imagine there's a parallel for you in Europe as well. So Tall Shadow asks, what about the need for soaking the brick before applying mortar? Is a little bit enough to keep the brick from sucking too much water out of the mortar, or soaking it more but having a lot of moisture and take a lot longer to dry? Yeah, that's a great question, Tall Shadow, and again, this is going to be really, I think, really specific to each individual's situation. So for, let's see, what am I trying to say here? Well, climate and storage are going to be the two main factors in whether or not there's a huge difference there. But I will say that when bricks are totally dry, bone dry, dry climate, stored inside, whatever it might be, then it helps quite a bit to to soak them a bit. Now, a fired clay brick, like a red brick, they can only soak up so much moisture. That's actually one of the biggest differences between a concrete brick and a red brick, which, contrary to what you'd think, you would think that the clay brick could absorb a lot of moisture, but it's actually the way around. The concrete bricks can absorb a lot more moisture. So what I'm telling you this for is to say, Tall Shadow, that I don't think you need to worry too much about over-soaking them. The worst situation to have is to have them so dry that they just, instantly dry out the mortar and they don't form a bond. So, frankly, I think if you're unsure, it's better to soak them. But I haven't ever felt like I needed to soak them for days. I usually just put the next row of bricks or the next few bricks that I'm going to do into a bucket of water, and they might just soak for, a few minutes before I get to them, and that's usually fine. So I do think that getting the bricks a little bit pre-moistened is important. I don't think you need to worry too much about them having too much moisture. I think that over time they can get really saturated, but it's not something that you really need to worry too much about. And yeah, I think that probably covers that. So, but you will notice if they're dry, you'll put the mortar on there, and the mortar will just like dry. You'll get a little like dry ring right around the mortar as it sucks the moisture out of there, and the mortar will tend to just fall right off those dry bricks. It won't bond at all. So do be aware of dry bricks. I would say be much more wary of dry than wet. Would be my suggestion. So So, geez, we've been going for an hour already, you guys. I don't know. I guess I spent a lot of time complaining in the beginning about my about my technical difficulties. I apologize for that. So Mark has a great answer there. He says, I soaked my hard fire brick until they stop bubbling, maybe 10 minutes. So yeah, that's a great way to do it. I mean, you don't need to get water all the way in through them, but you do just kind of want to fill all of the pores on the outside that are easy to fill. So if you can see those little fizzy bubbles on them, that's usually a great way to tell if you've, kind of got them beginning to be wet enough, is if those bubbles start to disappear. Great tip, Mark. Thanks for that. So I got a couple great emails from Always Learning this week, and I just wanted to touch base on those briefly because they were such cool physics. What is the word I'm looking for? Physics features that I thought were really neat and would be fun to share. So a couple things that he pointed me towards, and they're things that I've come across and have delved into prior in my rocket stove path here, but they were good reminders. And the first one was the Kármán vortex, and I've always thought this was so cool. And so this was when I originally designed my floor secondary air pre-port tube. I used a round piece of pipe for the vertical, which I still do use. And when I originally designed it, I was really of the mind that I was making these Kármán vortices in the lee of my pre-port air tube. And so I was really enthused when Always Learning, when you sent me that about the Kármán vortices, and I realized that when I responded to you, I did not respond about the vortices, and so I wanted to apologize that I overlooked that in my response to you, but I wanted to just let you know that yes, that actually was my goal and my original intention with that pre-port secondary air tube, was to induce Kármán vortices in the lee of that tube. In hindsight, I don't know if that's really happening inside a rocket stove. I actually tend to think it's probably not. I think there's too much going on right back in that area for there to be clean flow, as it were, to allow those vortices to form. But that was my original intention, and I do think that you guys, if you haven't looked, Googled them, Google the Kármán, Kárman, I believe is how it's spelled. Correct me if I'm wrong there. Always Learning, but they're really, really neat patterns that form in flow, and they are an excellent mixing element, and that is exactly what I was looking for. So that was one great email, and another email that Always Learning sent me was about pulse jets, which I've known about for quite some time, and we've used, talking with Peter and talking with I can't remember who else, but we have often theorized that pulse jet is kind of what the rocket stoves are doing when they're pulsing. When you have them, typically it's an overfueled situation, and they become something like a pulse jet where they kind of acts as a one-way valve. It's almost like a fluid diode. Because of the draft and the difference in temperature and difference in elevation, it's very difficult for it to flow back. And so it gets an induced flow one way, but it can't flow back, and so it just starts pulsing, and you basically get a pulse jet. But what Always Learning sent me was the Tesla valve, designed by Nikola Tesla, which is a one-way fluid valve using no moving parts. That's an important part of many modern pulse jet designs. They use this passive Tesla valve, which is just a configuration of physical shape. And I gotta say, Always Learning, that really inspired me. I think there's some interesting potential applications there in rocket stove world. One of the third video you sent me, where you can actually see how the Tesla valve increases the velocity of the gas through the path just by the nature of the shape of the passageways, is amazing. And I definitely think that there are some applications there in rocket stove technology, and I definitely have some it makes me want to experiment for sure, and my mind has kind of been churning since I watched that video. I was aware pulse jets, I was aware of a Tesla valve, but I didn't really understand exactly the nuances of the valve, and there's a lot of parallels to what's going on inside rocket stoves, just because it's fluid dynamics, but there's a lot of takeaways there. So really great emails, really great stuff. So for all you guys following along at home, highly encourage you to Google the Tesla valve used in a pulse jet, something like that. There's some great videos on YouTube. Some really interesting fluid dynamic physics involved, and some great rocket stove lessons just in the basic physics of that stuff. So all right, you guys. Well, I really apologize. We didn't get to the builds, and I'm just going to have to jump into that. You know, why don't next week, hopefully if I forget, you guys can remind me. Just say, hey, we're going to look at builds this week. But I have, like, pictures on, I mean, they're sitting actually on my monitor right now. They're stacked up, ready to go. So I have builds to show you. So why don't we come back next week? We've been going for an hour. I don't want to get all the people coming along afterwards stuck trying to catch up for 2 hours. So why don't we stop now for this week? You guys send me more photos, send me your builds, and let's come back next week and do a full episode just on builds. How about we do that? Tall Shadow says the Tesla rocket sounds really cool even if it doesn't work. Exactly. So yeah, so I think that's probably a good plan for that. Let me do my ad real quick. I keep forgetting about it. You guys know I have plans. Full rocket stove, rocket water heater, rocket cook stove plan sets available on my site, walkerstoves.com. So please go check it out. Purchase my plans, and you guys know I'm always here to help you build the best stove you possibly can. So yeah, Iron Bridge, hit me with a quickie. Shoot. I'm good with questions. No worries. Let's hear it. That's what I'm here for. But yeah, please check out my website if you haven't. Check out my plans. Let me know how I can help you build the best stove you can. That's what we're here for. So, all right. Iron Bridge Homestead asks, can I pour a leveling slab with Quickcrete? Yes, Iron Bridge, absolutely you can. I've done it more than once, and the only thing I'm going to say about that is, it's going to be... I do know what your build looks like, and you're going to pour... I'm assuming you're going to pour this leveling slab over your floating floor that you now have supported with those vertical piers underneath the floor. So, yeah, you certainly can pour a leveling slab with Quickcrete there. What I would do, Iron Bridge, is I would try to... I'm sure you're going to be limited a little bit in how thick you can make it because you don't want to make it too high, but don't make it too thin because it won't have any, compression strength if it's much thinner than like a couple inches. And if you can, reinforce it. Put contractor's cloth or chicken wire or something in there, because that leveling slab is really going to be what distributes the weight of your stove evenly across your floor. So if you can keep that thing in one piece, and you might even put hardy backer down on the floor underneath it, just to again sort of give it a sheet type structure and to carry that weight across all of your floor. I don't think there'll be any point loading, but those things might help. But yeah, you absolutely can, and I would encourage you to. I think it'd be a great base for your stove. So, all right. Glad that helped. So, okay, you guys, that's enough for today. I really apologize for technical difficulties and my frustration. Thank you for bearing with me. I will try to minimize those in the future. Man, the camera was working, then it just stopped. So, all right, well, enough about that. So, you guys have a great week. We're getting cold. Enjoy your fires. Make sure your firewood's put up nice and dry. And yeah, so I will be back next week. We'll do it again next Wednesday, 11 a.m. Can't tell you guys how much I appreciate all you being here. Thanks, everybody. I'm going to hit the outgoing video, and we'll see you guys next week. So, thank you, guys. See you guys next week.